In this question, we're given a chemical reaction, and we're given the enthalpies of formation of all of the things in the chemical reaction. So the chemical reaction is Fe2O3, solid, iron 3 oxide, commonly referred to as rust, plus 3 carbon monoxide, gas, yields 2 irons, solid, plus 3 CO2, gas. So this is the chemical reaction. And we want to know the delta H, the enthalpy of this reaction. And again, we're given the enthalpies of formation. To do this, we can use an equation. Delta H reaction equals the summation of N, the moles, times the enthalpy of formation of the delta HFs of the products, minus the summation of the moles times the enthalpy of formation of the reactants. And you may have heard this referred to as the enthalpy of the reaction is the enthalpy of the products minus the enthalpy of the reactants. Before we actually plug in the numbers, I just want to explain quickly why this is the case. Essentially, enthalpy is a state function, so it's independent of the path that we get there. So basically what we're doing is we're taking the enthalpy of the formation of the products, because we're going to form the products, and adding them to the negatives, or simply subtracting the enthalpy of formation of the reactants. So essentially, we're getting the enthalpy for forming the products from their elements, and we're adding it to the negative of, or subtracting the enthalpy of formation of the reactants, because we're going to assume that we're breaking the reactants into their elements, so we get the negative of their enthalpy of formation, because we're not forming them, we're destroying them. And then we're recombining all of those elements, and we're forming the products from their elements, so we get that enthalpy. And because enthalpy is a state function, this is a completely valid thing to do. Now we just need to plug in. Remember that enthalpies of formation are the formation of 1 mole. So we have to multiply them by the number of moles. If it's 1, we don't necessarily need to bother. In this case, the first product is iron. So we want to do products first. The first product is iron, and iron is an element, so its enthalpy of formation is 0. So you don't necessarily have to write this, but you could put 2 times 0 if you like. Plus, the second product is carbon dioxide. Carbon dioxide has an enthalpy of formation of minus 393.5 kilojoules. This is to form 1 mole. So enthalpies of formation are kilojoules per mole, but we're not forming 1 mole, we're forming 3 moles of carbon dioxide. So if we form 3 moles of carbon dioxide, 3 times as much energy will be released, so minus 393.5 kilojoules. Minus. Now we want to use the negative, or subtract, the enthalpies of formation of the product, or excuse me, the reactants. The first reactant is iron 3 oxide, so its enthalpy of formation is minus 824.2, and we're going to destroy one of them, so we're going to take negative of negative 824.2 kilojoules, plus the enthalpy of formation of the other reactant, which is carbon monoxide, but we're going to destroy 3 of them, so we take 3 times the minus 110.5 kilojoules, and we're going to make all these negative because we're going to subtract. When you do all this math, the enthalpy of this reaction is equal to negative 24.8 kilojoules. So this reaction is exothermic because it has a negative delta H, so and it's negative 24.8 kilojoules.